welcome. Here we are talking about slope of a line. The slope we're going to look at here is the slope of a line when we know 2 points that are on the line. Therefore, we know the coordinates of those 2 points, an x and a y for the first one, x and a y for the second one. So, what is the slope going to measure? Here's the key. Slope measures two things. The steepness, that's a weird word, I'm going to put it in quotes, and direction of a line. Technically, that's a vector because it has direction. And steepness is going to be a number. So it's either going to be positive where we don't write the sign, or negative when we do write the dash. And it's going to be a measure of steepness which begins as a fraction and may end as an integer, or it may wind up staying as a fraction. With slope, if you have an improper fraction, that's the way to leave it. Don't turn it into a mixed number because there's not a lot of benefit. In fact, there are a lot of things that go against the work we're going to try with slope. But slope measures steepness. Keep in mind that slope measures steepness. Now, when I come over here, I'll see that slope is equal to something called the letter M, as in monster. And you look at SLOPE, there's no M in there. So it seems a little weird that it would be called M. But I looked up what it is that caused people to use M for the letter for slope. And there are a few theories, but the one I like best and the one that seems most likely to work is M stands for monte in French, and I don't speak French, but anyway, it stands for mountain because mountains were steep, so they used M to represent slope. So that's where the M comes for the word slope. And it's going to mean that you want to know how much does it go up and down, and then how much does it go across, and set that up as a fraction where the top is how much it goes up and down, which has to be the y's. And then the change in x is moving across, and that has to be the x's. So it's got to be the change in y over the change in x, so I don't have to deal with the complaints of people saying, why did they do that? Can't we do the x's first again like we always did? No, we don't get to choose that because slope measures steepness. Slope doesn't measure how flat a mountain is, it measures how steep it is, or whatever else we're trying to measure. So we have to have the y's on top. And if you have two numbers that make up a fraction, we know that 3 over 1 is the number 3, and 1 over 3 is forced to remain 1/3, so you can't say, oh, it's just 3 or whatever it is. You have to have the correct number in each location to have the right steepness, because if you say 3 over 1, that means you go 3 steps up when you take 1 step across. Or if it's 1 over 3, you take 1 step up but 3 steps across, and that'd be the difference between a ladder and what we would see perhaps as a ramp onto a highway or something like that. Let me give you a quick look at that. Let's say that we have a ladder that's 25 feet long and it goes 24 feet up, okay, the side of a building. The building is perpendicular to the ground and this is 7 feet. Okay, so what that means is that you've got to be able to reach out 7 feet from the building to put your ladder down on flat ground, and then you'll be able to climb up a very steep ladder. That's not drawn to scale, but gets you the idea that this is a slope of 24 over 7. If I do start to divide, I see a number that's greater than 3. So you're going up more than 3 feet every time you go across the ground 1 foot. And it's making all these little steps of you going up. So it looks like stairs. But these stairs are going to be steep because the slope is bigger than 1. I got the same thing drawn. I've got 24 feet you're going across, or maybe it's 24 yards, but 24 something, they're all the same. And then you go up 7. So let's say that we have something where you're going 24 feet across the ground and 7 feet up because your car climbing up onto a highway. So yards might be better because yards are 3 feet, that's 21 feet. That's high enough that a truck could get under it. So let's say that it's in yards. Still, this has 24 on the side and 7 going up, and this would also have a 25, in this case, yards long ramp that you're going up. And that would not have the same slope. This one is going to have a slope of 24 over 7, which is a number bigger than 3, which means you go more than 3 feet up every time you move across the ground, like your shadow or something moves 1 foot. Whereas on this one, you're going to move 24 feet across the flat ground beneath this ramp and go up 7 feet. And this has a slope of 7 over 24. Just like negative and positive are different, the fraction 24 over 7 is different than 7 over 24 because the order that takes place when doing this fraction involves division, order counts in division. So just having a 7 and 24 involved in a slope doesn't tell me if it's very steep or not quite so steep. The other thing that can happen is we can go downhill. If I were to start up here and head back that way, this is still going uphill. Left to right, it's going uphill the way I've described our lines in the past. This one's also going uphill. We could have had a line that was going downhill, and I'll just take one of them. I'll take the ladder again. Let's say that you start at the top of the ladder and you're climbing down. So you're going this way. That's down 24, and then this is positive 4. Then that M would be negative 24 for climbing down and 7 for going to the right. And that would be a negative 24, and that means that our ladder is going downhill, right? And you can see this one's going left to right uphill for the first two I showed you. This one left to right is downhill. That would be a negative slope. Those are the two features of slope. Okay, so those aren't crucial parts. I'm still going to need that graph over there to show you what's going on when we do slope. But we need to find out if it's sloping up or downhill and how steep it is. That's what slope is about. It's measuring steepness, so you can't say, I just feel like I want to do the x's on top. You don't get to choose. What do other teachers call this? That's a good question, in case you've heard it before, okay? Now, if I had a full classroom, I would say, you've probably heard your teacher call it rise over something. This room is pretty empty. But what would rise be over? You might hear it as rise over run. Now, you know how I feel about the word just. Well, first of all, that's terrible. It does look like fun, and I like fun, but that's not the word. Run. So, what's happening if we're going downhill, and teachers have taught you as rise over run, you start going downhill, and I say, how is that ever a rise? And the teacher will say something like this, it's just a negative rise. I got two problems with that. Telling a student to visualize a negative rise is a very bad thing to do. I don't think that's helpful. It's going downhill. We can say that it's moving downward and that that's a negative movement. That's fine. We are going to need the dash. We can't just ignore the negatives. But I don't want to call it a rise. Did you also hear they said the word just? Just is a four-letter word in my classroom. If someone is saying just, you should always wonder if they're saying one of these two things. Don't worry about it. You can't understand it, which should be, offensive. Or don't worry about it, it doesn't matter that you understand it, which is a lie. I think it's helpful to understand what's going on. So I don't like just. I also don't like rise over run. There's another thing going on over here that's involving a couple of y's and a couple of x's. And that's going to be a formula. And a lot of you know I'm not a huge fan of formulas. I know how to use them. I know a lot of formulas. But it's not a good way to understand what you're doing. I'll fill out that formula later. If I give it to you now, everyone will focus on the formula and go, let me do it. One other thing, let me know about this one. When I start teaching you slope, some people will learn how to do it correctly, quickly, and say, that's so quick. I wish I didn't have to wait around for this whole lecture. Here you are. You're on a video where you could play it at a higher speed. If you play at a higher speed, my voice will go a little quicker and higher. I'll sound like Joe Pesci. Look it up. Or you can slow it down. If you need it to go a little more slowly, you'll still be able to understand what I'm saying, but I'll sound like a really slow southern drawl, kind of maybe Darth Vader. Cool, huh? Well, the trick is, somebody else told me it makes people sound drunk. But it's slower, so you can do that. So I'm not going to go really slowly because some people are going to take time. I'll let you slow it down. I'll let you roll it back. We have a benefit of being on video. The goal is when you're done watching this as many times and as quickly or slowly as you need to, I'm hoping you know how to do the problems that I put forth for you to do in the homework. So I'm going to go through at a regular pace. If it's too fast for you, slow it down. If it's boringly slow, you can speed it up. So let's take advantage of that opportunity. Here what we want to do is find the slope of the line through. And it's going to give you 2 points. So find the slope of the line through, and then it would be dot, 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 and would come up with what you have. And I'm going to say these 2 points. And I want to leave that up there. This is the only one I want to do on graph paper or in this graph situation. All the others I want to rely on taking our time to get you through the process to determine what rise over run is. So we're going to start with the point 2, 1, which is 2 for x, 2 to the right of the origin, and 1 above the y-axis in the first quadrant. There's my 2, 1. And we're going to end at the point 3, negative 4. So start back at the origin, 1, 2, 3, and then downward 1, 2, 3, 4. That is 3, negative 4. The other one was the point 2, 1. to handle a question like this, to even have a shot at doing it, they need to tell you both points. Three, negative 4. So my thought on this is what we want to do is go from this 2, 1 to that point 3, negative 4. But the first thing they want me to do is tell me how the y's change. So I'm going to start up here at 2. Sorry, not 2. Start at 2, 1. This is the y value of 1. And this has an x value of 2. Let's look at what's going on here. What do we get for the change in y over the change in x? I've got to get this other guy figured out as well. All right, this x value is 3. This y value is negative 4. I got to get this guy to go from 1 to negative 4. I got to get all the steps from 1 to negative 4. Now I can count them when it's small, but I could give you one where it's 1,037 goes down to negative 568, and that's a lot of counting. So I want to get it done on a small one and then come up with a process that I'll write over there we can use on bigger ones. Here it is. First, I have to get in the direction that I'm going. This is going down. So I'm ready to go over here and set up my change in y. M equals, actually I don't need to do that here. That's for later on when we're going to do our rules. I'll do it right up here where we're working on this one. M is equal to the change in y over the change in x. So let's watch what happens. I have to start at 1 and get all the way down to negative 4. My first move is to head toward it, and my first move is 1 step to get me to 0. So I've taken 1 step. I have other steps to take to get all the way down to negative 4. I'm going from the first floor in a building down to the 4th floor underground in a parking garage that's underground. And so I have to go 1 to get to the ground, and then number 2 takes me to parking 1. 3rd step takes me to parking 2. 4th step takes me to parking 3. And 5th step, I went down 5 steps. Down 5. There's something else going on here too. I'm starting at this spot where I'm on the 2 and I want to go to the 3. So I'm going from the 2 to the 3. And that's happening right here. I start at 2 and I go that way to go higher, so I go positively and I get a +1. That's a single negative, so I'm going to go with negative, and I'm going to reduce 5 over 1, but leave it as a fraction unless it's an integer. This comes out to negative 5. And therefore the change in y over the change in x is said to be negative 5. Now I'm going to put that back together for you and show you what we have. 1, 2, 1 right there. 1, 2, 3. 1, 2, 3, 4 right there. And that's a very steep line with a slope of 5. Some kind of 5. It's going downhill. It's not vertical, but it's going downhill with a very steep slope called 5. And that's what's going on, is this is negative going downhill, 5 steps down every time I take 1 step across. My step across is going positive, but my steps down are digging me down. So when I take this and I draw it in here, you'll see it's just a bigger version of the same thing. That goes on every time. That's the visual for it. I want to leave that for a little while, and I want to show you how I find the slope of a line. The first thing you do is you write the 2 points next to each other. You don't use them the way they're written. You don't say, oh, I can save 5 seconds and a micro speck of lead on my pencil. No, you write the points next to each other. It does not matter which one you write first, but you do write the points next to each other. And that's important because of what's about to happen. We're going to connect the y's on top. Make a little jump up and make a bar that connects the 2 y's on top. It must be on top. I have this line in between them. Number 3, connect the x's on the bottom. Because change in y must be on top, change in x must be on the bottom. I'm going to show you how that happens here. I have 2, 1, and I have 3, negative 4. what we're looking to do is on top we connect the y. So I go to this y, I don't grab that 2, I grab the 1 connected to -4. I take the 2 and I connect it to 3. What you're trying to do is determine each change. Could be positive or negative. Determine each, which is both, but both is at the exact same time. Each is in succession, so each change value. That change value is called a vector. Sometimes they go up, sometimes they go down, sometimes they even stay on 0. Like they stay with no movement. How do I get on a number line from 1 to -4? That was actually pretty easy to see here, but I'm going to clarify it even a little bit more. I'm at 1, here's my 0, and I have to go 1, 2, 3, 4 down. That's why I know I have a negative value. And how far is it from this 1, which is above, all the way down to that -4 by going through the 0. What I call it is through the 0. When you go through the 0, you make a big number. You use 1 and 4 and make a big number. This is how easy it is. If you have 1 and 4, your choices are to make that into 5 or 3. If you want to make a big number, you're going to make 5 because you're going to add a regular 1 to a regular 4 and you're going to get 5 for a big number. And it's going to be bigger than the 1 was, it's going to be bigger than the 4 was, and you're going to have a big number. It's exactly what happens here. I get -5. The negative was already established, the 5 goes in. That went down 5. It happened pretty quickly, but let's look at the other one. We have the x's, which go from 2 to 3. Here's my 0. Here are my two numbers, 2 and 3. That movement from 2 to 3, and it did start at the 2, go up to 3. You see it going up. And I do it up and down. I don't do it across. I just do it up so that you can clearly see it's going up. It's going to be positive. I'm going to put the plus here. It did not go through the 0. It's up, so it's plus. This was downward, so it's minus. Those signs are locked up by the work we do. And then this. We say to go from 2 to 3 is a short trip. Why is that a short trip? Because it didn't go through the 0. Anything through the 0 is a long trip. Anything not going through the 0 is a short trip. This is a short trip. 3 and 2 make it small. 3 minus 2 gets you 1. Therefore, that's +1. And so we have a short uphill trip of 1. This had a long downhill trip of 5, each in their own place. -5 over -1. You just keep them where they are. -5 over +1 gets me -5. You know what that matches? The slope that the graph would give us. When you do that, you simplify the fraction you see, but not to a mixed number. If it's going to be an integer, great, write the integer. It's over 1, you can leave it over 1. It'll help you get some jobs done. If it's 7 over 3 and you try to reduce it, it's still 7 over 3, you leave it as 7 over 3. That's going to help me say that if it's 7 over 3, up 7, right 3, I'm good. If it's 5 over 1, 5 is good for us. Or if we get, 16 over 8, we can make that 2 over 1 or 2. And that's what it's going to make. So that's the set of instructions we're going to use for those. I'm going to break here so that I can erase the board. We're going to do a bunch of these without the graph. You have the graph available. You can go over it a bunch of times, but every one of these is going to do it. I'm not doing the graph every time. We're going to just fly through some of these numbers. Great. We'll take a look. We're going to continue here. It's still part of lecture 15A. You might call it 15B, but it's not a new subject. So I'm going to say this is just a little bit more of that. I want to find the slope of the line between -2, 1 and 2, 2. So this is saying find the slope of the line between these 2 points. And here we go. -2, 1, and then 2, 2. So I always say you should write it again. So I will. -2, 1, and 2, 2. You should be able to see your original problem untouched when you go back to look it over. So we connect the y's on top and the x's on the bottom. And what we have going on here is we're going from 1 to 2. 0 is here. I'm at 1. I go up to 2. Question 1, does that go up or down? From 1 to 2 is up. Does it go a long trip or a short trip? Does it go through 0? Same answer to both of those questions. It does not go through 0, so it is not a long trip. It's a short trip. The short trip between 2 and 1 is 2 minus 1 and gets me 1. So that was going uphill, as I said earlier, and it goes up 1. Now I got to do this other one. I got to go from -2 to 2. So here we are. We have our -2, and we have our 2, 0 lies between them. And here's what's going to happen. I'm starting at -2 and I'm going to that 2 that's way up there. Going up to get to 2. So therefore this is going to be going up. And now I take 2 and 2. They're both 2 and I want the big number. Because it goes through 0, I need to make a big trip which is bigger than that 2 is and bigger than that 2 is, and I get a 4. I don't get a 0 here, I get a 4. Slope equals +1 over +4, and we call that 1/4 with no changes to it. I'm going to come over here and keep our score. Slope of that line, 1/4, positive. Next pair of ordered pairs. 1, 3, and 5, -3. 1, 3, 5, -3. Those are the pairs. And so I'm going to write 1, 3, 5, -3. It doesn't matter what order you put it in. When you finish reducing your fraction, it'll come out the same exact fraction, fully reduced, either way. Most people leave it the way it is, but there's no harm if you were to switch the order of the entire pairs. If I wrote 5, -3 first, I don't say, oh no, I wrote the wrong one first. It's going to be fine. I do have to connect the y's on top from 3 to -3, and the x's on the bottom from 1 to 5. So what we have here is for our first top, we're at 3 above. Down here is 0, and then our -3 is down here. I have to go from my 3 down to -3, from my +3 down to -3. So because I go downward, I'm going to put a negative. And 3 and 3 are going through 0 to get that to happen. So I'm taking a long trip. I got to take my first 3 steps to get to 0 and my next 3 steps to get the rest of the way. Go 3 flights down from your 3rd floor office and 3 flights deep into the underground parking lot. Total of floors that you went down is 6. It's downward 6. The downward is established before you do anything with the numbers. And then this is a big trip from 3 to -3, downward 6. 1 to 5. Got my 0 here. My 1 is up here positive. My 5 is up here as well. So I did not go through the 0 to get that to happen. What happened here, someone was on the 1st floor. They had to go up to the 5th floor of the building. So they had to go up. So we're going to put plus. Now it was a short trip. They did not go down to the ground, hitting 0, and then keep on going 5 floors into the ground. They stayed above ground the whole time. In fact, they had a head start on getting to 5. It's going to be a smaller option. My options that this can make is 6 and 4. 6 is with adding, 4 is with subtracting, and this is a short trip, and for that reason I get a 4. So my slope is equal to -6/4. It is negative, it's got a single negative on it. 6/4 reduces to 3/2, and therefore the slope of this line will be -3/2, down 3 steps when I go to the right 2. And so that's going to be -3/2. Fully reduced, that winds up being a negative slope. It's going downhill. We don't need a graph every time. The next one is 5, -7, and 6, 2. 5, -7, and 6, 2. So I have my points next to each other and ready to be worked on. 5, -7, and 6, 2. And so we go from -7 to 2, and on the bottom 5 to 6. So we go ahead and we put our -7 down here, 0 is above it, and I got to go even further up to get to my 2. I have a long trip ahead of me. They don't have to be drawn to scale. But I have to take 7 steps up to the ground and 2 more to get to the 2nd floor. So I'm definitely going up. You can see my pathway from here is going up, and it actually goes up from this -7 through the 0, so 7 to get to 0, 2 more after that, up 9. Not a 2, not any kind of 2, not a 5, sorry, not a 5. We used 7 plus 2 to get a big trip of 9. If we had to do 7 minus 2, we'd get a small 5. Like if I went from -7 to -2, that'd be a short trip, or +2 to +7, short trip. But we go through the 0, it's a long trip. 5 to 6, both positive. So I got my 0 down here. I'm starting at 5, winding up on 6. I gotta go up from 5 to 6. I go with positive. 5 to 6, that is a very short trip. I'm not going 11 floors to get from 5 to 6. I'm taking a very short trip. My 0 never gets involved in this. I just stay on the upside. I go small. 6 minus 5 gets me a 1. M equals 9 over 1. No negatives in sight. That can be called 9. Now we have this one, where we have negative 3, 6, and 3, 9. Negative 3, 6, and 3, 9. Negative 3, 6, and 3, 9. I'm going to write them. Negative 3, 6, and 3, 9. Sorry, no comma there. So I go from 6 to 9. If you can get away from writing that, that's fine. 6 to 9 does not go through 0. It stays on the positive side. So I'm going to go from 6 to 9. But here's my 0. Start at 6, going up to 9. Up 3. A short trip up from 6 to 9. Negative 3 to 3. Separate one over. Here's my 0. Start down at negative 3, wind up at 3. Got a long trip here. Among the options that the 3's can give me are a 6 or a 0, but this is a long trip. 3 steps up to the ground floor, 3 more steps up to the 3rd floor. I got a total of 6 steps. I'm going up the whole time, so it's up 6. M equals 1 over 2. Done. 1/2. Now what if I did that same one by reversing the order of those to have the 3, 9 come first and the negative 3, 6 come second? This is true of all occurrences that you can have. If you go from 9 to 6, you're going to have a negative movement. From 9 down to 6 is going to be down 3. And from 3 to negative 3, you're going to go from a big positive 3 through the 0 to negative 3. That's a negative 6. You wind up with the opposite of negative. You wind up with 3 over 6. That's positive, and it gets you 1/2. You might think, oh, I guess it worked that one time. It works every time. So if you get the points in a different order, you might have more negatives or different negatives to deal with, but the answer will be the same. So I have one more that I want to add here. I want to add this one on the fly because I want you to see that this approach can work pretty well for even the most hideous kind of problems, which is when we have work going on all underground, such as this. If we have something going negative 2, negative 7, to negative 8, negative 4. Okay? This one's all negatives. That's nasty, especially if I show you a formula, which is a plan coming up in a little while. Here we go. I have negative 2, negative 7, and negative 8, 4. So there they are. I need visuals might be necessary, especially when you have bunches of negatives. Anyway, negative 7 to negative 4. This is a case where people are both in deeply down underground parking their cars. And what happens is we have one person is down here at negative 7 and he has to go up and meet someone. I'm sorry, I gave it away. He has to go meet someone at level 4. All underground, still has to go up, plus, and doesn't go 11 steps to get there, only goes 3. It's a short trip. 7 minus 4 gets you that 3. We also have someone starting at negative 2, the 2nd floor underground, has to go down to find somebody at negative 8. Now, normally you would go up toward the ground, but maybe they have to do something like get in the car. This car's broken. It's not starting. It says, all right, meet me down at my car then. I'm down at 8. Better know that you have to go down to get there. Furthermore, don't go down 10 floors. You'd be down at negative 12. If the floors go down that low, you're not going to find the car there. This is a downward movement. And it's a downward movement that's short. 8 and 2, big would be 10. We don't have that going on. We're not going through 0. We have a short path with 8 and 2, and that gets me 6. This gets me a slope of positive 3 over negative 6, and is going to make negative 1/2. So we'll stop there because I want to now clear the board so we can do the same problems with a formula.